All right, we're going to be looking at section 311 over topics called related rates. So we're just going to do go through the book's examples. They got a bunch of good examples in there, so we're going to go through, take a look at those, and the ones that they give, the examples they give in the book. These are also common ones that would be on the AP test. We'll just go through and take a look at it. So example 1 here, they tell us 5 meter ladder. So 5 meter ladder leans against a wall. Okay, so a 5 meter ladder leans against a wall. The bottom of the ladder is 1.5 meters from the wall at time equals 0. So the bottom of the ladder is 1.5 meters away from the wall at time equals 0. And slides away from the wall at a rate of 0.8 meters per second. And we want to find the velocity the top of the ladder slides down the wall at time equals 1. So picture of what we got. We got a wall, we got a ladder. This would be at time equals 0, I guess. We know the ladder is 1.5 meters away from the wall at time equals 0. The ladder itself is 5 meters long. And then the ladder slides down the wall, and at time equals 1. It's probably not that much, but time equals 1. The 5 meter ladder now is down the wall a little bit because the bottom has slid out some. So what we're going to do is we're going to come up with some variables. We know that this 5 here is always 5. We're going to call the bottom down here x. X changes with respect to time. We'll plug in for it in a little bit. And we're going to call this h for the height the ladder is. And then we can get equation x squared plus h squared equals 5 squared, just the Pythagorean theorem for this triangle with the ladder. So we'll say that's x squared plus h squared equals 25. Now what we want to know, it's asking us what's the velocity of the top of the ladder at time equals 1. So it's asking us what's the change in the height with respect to time at time equals 1. This is what they want us to find. So what we're going to do is we're going to apply ddt to both sides of the equation. And since both x and h change with respect to time, when we do ddt of them, the chain rule will apply, and we will kick out a dx dt and a dh dt. So when I do ddt of x squared, I get 2x times dx dt. So chain rule applies. I get 2 out there. I get x itself, and then the derivative of x with respect to time, because x is a function of time. As time goes on, x increases. And then we're going to add to that 2h dh dt, because h is also a function of time. As time goes on, the ladder slides down the wall. And that equals ddt of 25, which is 0, because the derivative of a constant is 0. So we're wanting to figure out what is dh dt. So we're going to solve this equation here. We're going to solve this equation for dh dt to get dh dt by itself. So I'm going to slide that across the equal sign as a negative. So we'll get 2h dh dt equals negative 2x dx dt. We're going to divide by 2 on both sides to get rid of the 2's, so they'll cancel. And then I want to divide the h across as well. And so what I'll get is dh dt equals negative x over h dx dt. Okay, dx dt, the problem told us that. That's the rate that x changes with respect to time. And it told us the ladder slides away from the bottom at a rate of 0.8 meters per second. So we know the dx dt in this is going to be 0.8. The problem told us that that is the rate the ladder slides away. Now, the problem is this triangle here is for time equals 0. And we know at time equals 1, the ladder is slid down a little bit. So we're going to go through, and at time equals 1, we need to go through and figure out what's the x value, what's the h value at time equals 1. So we'll say time equals 1. The ladder is slid down a little bit from where it originally was. This is probably way too drastic of a slide, so let's say maybe it's more like that. So we'll say at time equals 1. We need to figure out what's the x value here, and we know that the ladder itself is 5, so we need to figure out what's the x length and what's the height. So the x length, they told us at time equals 0, the x length is 1.5 meters away from the wall. So it's 1.5 meters to get started. That's at time equals 0. If the ladder slips away at 0.8 meters per second, and time equals 1, that's 1 second after time equals 0, the ladder will have slipped a 0.8 meters away. So we get 1.5 plus 0.8. This equals be 2.3. So 2.3 will be our x value at time equals 1. It's time equals 0, the ladder was at 1.5. In the 1 second, the ladder slipped. Since it slips at a rate of 0.8 meters per second, the ladder slips over an extra 0.8. So 1.5 plus the extra 0.8 gets us 2.3 there. And then we can use the Pythagorean theorem, and if we have this, then square root of 5 squared minus the 2.3 squared, that will be our missing leg here. So when we plug in, for x we get 2.3, and for h we get the square root of 5 squared minus 2.3 squared, and that's just using the Pythagorean theorem on this triangle. Since we know this side, we know that side, we can use this to figure out the remaining side. And at this point, we're ready just to plug these values in. So what I put in my calculator is 2.3 over square root of 5 squared minus 2.3 squared. And then that all gets multiplied by a 0.8. So that'll be dh dt. And let's see here. It's 2.3 divided by square root of 5 squared minus 2.3 squared, all that times a 0.8, and that gives us dh dt. I'm going to round it to 3 decimal places. It's 0.414, and the units on this, it's negative 0.414, and the units on this would be meters per second. So this is the rate the ladder slides down the wall. It's negative because the top of the ladder slides down. So this is the rate. Top of ladder slides down the wall. Okay, so that's the first example.